welcome to another EarthEcho snack size science.
That's right. Today is another fun, easy experiment that you can do at home, and it's called Fantastic Filtration, and it's all about filtration. Shocking.
Right. Now, the star just left.
Yeah, our co-stars.
Well, she's the star, let's be honest. We're the co-stars. She just left. That was Kenai Cousteau. But we are here to take you guys on this experiment. So thank you for watching with us. If you guys have any questions, please ask away. We have people standing by to answer your questions.
That's right. And all these tools and resources, like these worksheets about how to do this with the ingredient list and everything, is all available on our website, as well as is so many of our archive snack size science that we've been doing twice a week for the last more than a month now. So very excited to continue adding to these.
Now, Philippe, why is filtration important?
Well, you know, only about 3% of Earth's water is fresh water. And there's no more fresh water today than there has ever been in our history, at least of our current climatic history.
Because it's all in part of the same water cycle that just literally keeps cycling through.
Because most of our fresh water, of course, is locked up in ice. So 3% of our Earth's fresh water is accessible. And as I said, there's no more today than there was 1,000 years ago or 1,000 years before that. So what we do with that water and taking care of that water is very, very important. And the first step, we believe in that, is to take stock and understand how our water is filtered on Earth, essentially, right?
Right.
So today it's all about how this natural process of filtration occurs, because water doesn't come out of the tap.
Yeah, a lot of people assume, at least in this country and in many other countries, that water just bloop, comes from the tap. But no, that is not where it comes from. It comes from your local aquifer. It gets pumped through. It usually, in California, we don't have a lot of natural water, so it gets pumped in from other areas.
Through river water. So water comes from a watershed somewhere,
Yeah.
right? As Ashley said, either through an aquifer, groundwater, rivers, whatever it may be. And nature has a really wonderful way of naturally cleaning that water, and that's what today is all about.
Okay, so we are going to start with the materials, okay?
Yes.
So you need a plastic water or soda bottle or a large funnel. Now, I have to be honest, it took Philippe and I about 3 days to try to find a plastic bottle. We had to go ask our neighbor for one.
Yeah.
This was a hand soap bottle.
We try and cut the plastic out at home.
Yeah.
So.
Or you could also use a funnel. This is our silicone funnel, but we figured that you guys probably couldn't see it very well. So, hence the reason we asked our nice neighbor if we could, well, have their plastic bottle, because we're not going to give it back to them. Okay.
That's right.
So, you need that. We need a tall vase or a tall glass, drinking water glass. We need some cotton balls.
Or a piece of cloth, something like that. Here we have that here.
1 to 2 cups of small gravel or pebbles.
There we go.
1 to 2 cups of clean sand.
Yes.
1/2 cup of activated charcoal.
Very important.
Which is actually used in aquarium filters, and or sometimes people drink it or take tablets of it.
Yep.
But yeah.
Yep. So we got this at our local pharmacy, actually.
Local health store, yep. Okay, we have another cup to pour in stuff. We got the water, and then we have things to make dirty water. Our dirty water is going to be some of my coffee grounds. Yes. Yeah. And then scissors or a knife, which we also have. So,
First step
is using scissors or knife, cut off the bottom of the plastic bottle. Kids, you should ask an adult to do this or supervise. Philippe, I will supervise you.
I was gonna say, I don't know if I can be trusted with this. So good.
So yeah, you want to cut off that, not the skinny side, but the big side.
Because you're gonna use the big side, of course, as the funnel bit. So
the little side as the funnel bit. That's what he meant.
the little side. That's exactly what I meant. I was just testing to make sure she was paying attention to me.
Are you guys paying attention? Okay, good.
All right, this is our makeshift plastic funnel. And what's next, Sharon?
So next is remove the cap. Well, we already did that.
Did that, no cap.
And stuff the opening with cotton balls or a small piece of cloth.
Okay.
This is the bottom layer of your filter, and it should be about an inch thick.
There we go. I think that's about an inch.
Yeah.
That looks pretty good. Okay.
Okay. Next, place the bottle neck side down in the vase. So let's make sure you guys can see this. Can you guys see that? Yeah, they'll be able to see that. Okay, I'm moving that funnel. So I think you place it upside down into this.
Okay. Boom.
Oh, I'm glad that fit.
Yeah. It would have been awkward if it fallen through or not fit.
Okay, next, build your filter by adding layers in the following order. Now, do you want me to do that, or do you want to do that?
Why don't we switch off?
Okay, what's first?
Following order. 1 inch of activated charcoal.
So Philippe gives me the dirty job.
Yep. This charcoal does get like everywhere.
Yeah, try.
So
I was gonna say, try not to sneeze.
I think you probably pour it all in. Right?
I know. I'm just trying not to get it in all over the ground.
Oh, well. Well done.
Okay,
Well done.
couple drops.
Better than I would have done.
Couple drops.
Okay.
Next.
Then there's 2 inches of gravel. Okay, so I get to pour in the gravel here.
I hope your cotton is nice.
Whoa.
Oh, geez, nice and sturdy.
Oops. Hence why we're doing this outside. Okay.
Okay, that's good. That's good. I think because we need to add some space at the top.
Alrighty.
Okay.
What else do we have to put on the top? Is it 1 to 2 inches?
Yeah, but then sand. Then we
Oh,
have
and
to do
then
sand.
a little bit more gravel. Alright, so then we put in some sand.
Uh-huh.
You want to do the sand?
Yeah, because I think I'm a little better at...
Yeah, I'm good.
No, I can... See? You just gotta go slow.
You gotta finesse it.
Okay, let's see.
Looking pretty good.
Okay, just a little bit.
Okay.
There's sand.
Then we put in some gravel.
More gravel.
Okay.
Whoop!
Whoop, isn't it?
But it says try to leave an inch at the top, so try to leave
Okay.
some at the top.
Okay, so I'll just put in.
I think maybe we cut our bottle a little too short, but that's okay. Oh, perfect.
Oh, no, I think that works. Okay.
And I have to be totally honest with you all. Philippe was setting up the experiment, and I walked by the bowl, and it was these tiny little things, and I, at first, thought that they were baking chocolate chips, and I literally had my hand like in the thing until I realized that they were not chocolate chips.
She's a bit of a chocoholic.
They were gravel. So I'm glad I didn't eat them.
Yeah, so am I. That would have been a quick trip to the dentist. Although, I don't know if the dentist is open.
I don't know if they are.
Anyway, that would have been
Okay,
bad.
so
Okay.
now in a large measuring cup or bowl, prepare your dirty water by adding several spoonfuls of soil or coffee grounds to water. If
Torn
desired,
paper, glitter,
glitter.
even. Yeah.
We don't have any glitter around
I
the
don't
house
have glitter
yet.
We have a daughter. She's only a year though, so she's not into the glitter yet.
Yeah. So should we just put in the coffee grounds? Should I put all the coffee grounds in there, or should I put it in here?
I think coffee grounds in here, dirty water. Let's see how it
Okay.
works. Okay.
Well, and there's some dog hair in there, so that's
Yeah,
great.
so we got dog hair, coffee grounds.
Okay, I'm gonna
This is
stir it
good
up with my
stuff. Stir it
finger.
up. All right, all right, all right.
Okay.
Okay.
And then
Fingers
slowly
crossed
pour
this
it
is gonna
in.
work. Let's see here.
Oh.
So what this is doing is this is mimicking how water percolates through the ground and is filtered naturally by things like sand and gravel or limestone, which, believe it or not, is porous. Most aquifers are surrounded by limestone or are limestone, because most aquifers, you know, they're not like a big pool of water underground. They're actually porous rock that water lives and soaks into, that you're able to draw water out of. So look at this nasty water at the top here, kind of gross, and we're just going to give it a little bit of time because it takes time for this all to filter through.
Or Philippe packed the cotton too tight. It's okay. Have faith.
Now listen, that's what experimentation is all about. We know it's gotten through the sand, now it's getting slowly going through the charcoal.
Yeah, I think it's going through the charcoal. But it's so interesting because when you look at this, you can see all the different levels, and that's like all the different levels and different types of soil that we have.
That's right, that you'll find in the earth. And so what's happening here is, you know, this coffee ground, these are an organic material, right? So this is expected to be filtered out by this type of system, which mimics the earth and the natural filtration process of the earth. But we have something to try a little bit later after this, though I don't know how long this is going to take. We'll see. that is a colored liquid to mimic chemicals and
What?
things like that. So, is there any water coming
No,
out?
that was from the outside.
Oop. Because
No, the cotton's not even wet.
yeah. But we have a little bit of charcoal in here. Oop.
Oh, is it coming?
So it's going to be dark. No, it was from
No.
the spilling. Okay.
Well, we're gonna just let this sit. I see drips, but I think that's from the spillage. But why is this important? Why is it important that this natural process doesn't get interrupted?
So part of this is essentially most of our water is filtered like this, right, on Earth. And still, a majority of people get their drinking water or irrigation water, agricultural water, from groundwater sources. And so if that water isn't cleansed properly, either through the destruction of the ground, the hardening of the ground, for example, when there's farming and agricultural practices that will go in and compact the soil, maybe soak through agriculture over time, really draw all the organic material out of it, and leave that soil to be hard and compacted. It's basically like asphalt, and the water will run right off of it and into streams, into rivers, and into the ocean. Whereas historically or traditionally, that water would be soaked through the ground and slowly percolate through and filter out. And so that's one of the problems with, you may have heard of permeable and impermeable surfaces, right? So permeable surfaces are surfaces that you can get through. Impermeable surfaces, like asphalt or the cement here or this stone, are impermeable, means the water can't get through them. So when you cover cities with these impermeable surfaces, you end up having this situation where water lands in rain or snow or sleet or hail, whatever it may be, and it ends up just running off the land as opposed to soaking through and going through this process. So there's a lot of water now in the charcoal. This is heavy.
And there it goes! Yay!
It's starting to drip through, and it's crystal clear.
So, I think that one thing to always remember, like Philippe was saying, is just healthy soil goes hand in hand with healthy water. And to have healthy water and a healthy watershed, you need healthy soil.
Yeah, and you need land that allows the water to flow through it, not over it. And that's critical to maintaining water supplies and healthy water supplies around the world. This is taking a long time. We're going to do a close-up. I'll bring this up and show it to you in a close-up. But essentially, so what we're going to do is demonstrate how one of the other problems that we find with groundwater infiltration is things like chemicals that are so fine because they're essentially liquid that they circumvent this process. They go along with the water and down through. And so when we apply chemicals and pollutants like that to groundwater systems, this natural filtration system might not remove those chemicals. Things like PFAS is a great example. There was that movie with
Dark Water.
That's right. That was all about that with Mark
Yep.
Ruffalo, or other chemicals that make it into our groundwater system, and then that we consume and that aren't filtered out through these traditional methods. And so it's really important to think about how we don't circumvent this. And EarthEcho has a program called the EarthEcho Water Challenge. It's one of the world's largest citizen science water quality testing programs. We've all heard about the water crisis in the world today, and the fact that a lot of people don't have access to enough water. But another crisis is access to clean, healthy water, and that starts at home. We believe that taking control of water starts by doing experiments like this with your kids and understanding how the system works.
Or with your parents.
Or with your parents. That's right. Parents usually need to be taught a lot more than the kids do.
Yeah.
So yes, water is slowly making its way through here. It's dripping through.
This also just goes to show, because Philippe and I do a lot of camping, and obviously water is essential for life and for us humans. And it is when you really, because when you're camping, you have to try to treat your own water, and it takes a while. And it just reminds you how important water is to all of us humans and all of us beings on this planet.
Yeah. Water is
Because what do we look for on other planets? Water.
I always find that curious that, we always, I won't go into my space rant here, but we like to head off into space and look for, other civilizations and life in space, when we have so much life that we need to protect and make sure is thriving here on Earth. And I would argue maybe invest a little bit more in that. But yes, water is right in our backyards and something we take for granted.
Oh, we have a helicopter. Not us. There's a helicopter flying there. It is slow. You can feel it.
It's wet, right?
Yeah, and when it comes out, it is just clear.
Yeah. Here, let's
Yeah.
let's bring it up close to the camera here. Now I have some activated charcoal on my fingers, so that's not doing well.
And it doesn't want to focus very well. Okay, here we
No.
go. Can I squish any out? Oh, there we go. See? And it's just nice, clear water.
Now, this also mimics the function in nature that this is a very long process. Like,
Yes.
this takes a long time in nature for water to percolate through. So when you deplete an aquifer, in other words, when you pull too much water out of that aquifer, any groundwater supply, it's not like one rainstorm will replenish it overnight. It takes a very long time for these natural systems to work the way they're supposed to work. They don't necessarily work on a time scale that we would like them to. So that's also important when we read about or when we learn about or hear about how much water is being pulled out for agriculture. Here, for example, in the Central Valley in California, there's a lot of concern that farmers are pulling water out of their aquifers faster than it can be replenished. Because as you can see here, it's a very, very slow process. This would probably take a couple hours to drain all of this through here, but it would be really clear, clean water because those organic compounds, the coffee grounds, are being pulled out. Now, if there were chemicals in this water, that wouldn't necessarily be pulled out of this process, and that's, again, something we want you to be thinking about. So there's also a program called Water by Design, an expedition that we did at EarthEcho that's all about water scarcity, and we have lots of other resources and tools on our website that you can check out. We'll be pulling up a slide about that. Remember to ask for questions. Keep asking questions on social. We got people monitoring this. Thank you for joining us for another Snack Size Science and fantastic filtration. It's slowly coming through. It's working.
It's working.
It's working. But
Success.
nature takes time. Success.
Nature takes time.
Yeah.